So we know that an infinite series is just the sum of all the terms of an infinite sequence. So now the question arises, great, now that we know that, what is the value? What is that sum? How do we find it? Can we find it? And the way to really go about it is to look at basically, well, we can't add up all the terms piece by piece. That's just going to be impossible because we're talking about an infinite number of terms. So can we actually find some mini sums or some partial sums? All right, and that's what we're going to start looking at first, are the partial sums. Okay, so the first partial sum, that's just the sum of the first term, or which is itself. All right, so the first partial sum is the first term. The second partial sum will be the sum of the first two terms. The third partial sum will be the sum of the first three terms. All right, so and then so on and so forth. And the nth partial sum will be the sum of the first n terms. So the question now becomes, well, is the sequence of those partial sums heading towards a certain value? Well, if it is, then we say that the series converges. And whatever value the limit is heading towards, that will actually be the sum of the series. If not, then we're going to have a series which diverges. Right? So let's look at a quick example, which you see on your paper there. What are the first four partial sums of the sequence 1 over 2 to the n? Okay, so let's look at this. The first partial sum will be s sub 1, right? And it's just the first term. So the first term is when n is 1. So we have 1 over 2 to the first, or a half. Right? Now we get the second term. Well, it's going to be equal to the sum of the first two terms. We already know what the first term is. It's a half. Okay, and now we have to add in the second term. All right, so now n is 2. So we have 1 over 2 squared. So we have a quarter. Right? And if we add a half and a quarter, we get 3/4. Right? Then we take a look at the third partial sum. So we already know that the first two terms add up to 3/4, and now we have to add in the third term as well. So we've got 3/4 already, which is a half plus a quarter, plus the next term. If n is 3, we have 1 over 2 cubed, that's 8, so 1 over 8. So 3/4, which is 6/8, plus 1/8, gives us 7/8. That's our third partial sum. And we have to do the first four, so we go with one more. All right, the fourth partial sum is the sum of the first three terms, which we already know is 7/8, plus the fourth term. All right, so 2 to the fourth, that's going to be 2 times 2 times 2 times 2, that's 16. All right, so we have 1 over 16. 7/8 is 14/16, so we added one more, so we have a total of 15/16. All right, and we can keep going, but basically we're interested in a new sequence of these partial sums. All right, so our new sequence, all right, is 1/2, and then 3/4, and then 7/8, and then 15/16. All right, and the question becomes, what's the limit? This is our sequence, if you will. All right. All right. What's the limit as n approaches infinity of the sequence? Are these values right here, are these partial sums converging on a certain term or a certain value? And I think we can see there that, yeah, we're going to be getting closer and closer to 1. All right. And so we know that's actually going to be the sum of all the terms. All right. So the sum in general, just s, is equal to 1. If we were to add up all the terms, a half plus a quarter plus an eighth plus a 16th plus a 32nd plus a 64th plus 1/128th, so on and so forth, all those numbers are going to add up to 1. Right? And they would do that by looking at the limit of the partial sums.